Welcome to This Explainer. Okay, today we are going to unlock the secrets of literally the most complex organ in the known universe, your brain. We're going to be breaking down this incredibly fascinating framework from Dr. Vidita Vaidya, who is one of India's leading neuroscientists. Her insights actually map our everyday behaviors, our mindless scrolling, our daily stress, our big successes, directly to our brain's biology. So let's dive right into this and discover how your biological hardware completely dictates your daily habits. So here is our roadmap for today. We'll start by mapping the physical brain, then explore plasticity and memory formation. Next, we'll dive into the mechanics of addiction, understanding modern anxiety, and we'll wrap up with the neuroscience of willpower. All right, Section 1, Mapping the Physical Brain. To truly understand our minds, we really need to look at the tangible building blocks first. And honestly, it's wild, but these blocks are remarkably similar across all mammals. Think of them kind of like Lego pieces. The exact same basic blocks can build a tiny toy car or a massive spaceship, right? Notice the distinction here between gray matter and white matter. Your gray matter is where the actual brain cells, the neurons, live. They're the signal producers. They literally create your thoughts, your movements, your memories. But those signals are totally useless if they don't actually go anywhere. And that's exactly where white matter comes in. White matter is basically this massive bundle of cables carrying those signals away from the gray matter all the way down your spinal cord and out to the rest of your body.
Now, one of the absolutely biggest differences between us and other mammals is the cortex. That's the folded outer layer of the brain. If you took the cortex of a rat and flattened it out completely smooth, it would only be about the size of a 1 rupee coin. A goat's, that'd be about the size of a small puri. A monkey's would be a large chapati. But a human brain? If you flattened our cortex out, it would literally be the size of a large pizza. But since we obviously don't walk around with giant pizza-sized skulls, nature came up with a pretty brilliant workaround. The brain just folds in on itself, over and over and over, creating those distinct wrinkles, just to pack all that massive surface area into our relatively small heads. Moving on to Section 2, Plasticity and Memory Formation. So how does this physical hardware actually adapt to the world around it? Well, through neuroplasticity. This is where we kind of transition to the brain's operating system. Dr. Vaidya points out that the brain is a pattern-completing machine. It's constantly taking in new information to adapt. But here's the catch. It doesn't stay endlessly flexible forever. The first 25 years of your life offer this incredibly critical window. During this time, your brain's ability to change its actual physical structure in response to your environment is at its absolute peak. It is essentially the foundational era for your entire mind. To really visualize this, think of an interior decorator. It's crazy to think about, but even if you took identical twins with the exact same genetic blueprint, their brains would not look identical at a microscopic level. Why? Because they don't live identical lives. The basic rooms of their brains are in the exact same location, sure, but their individual life experiences, the food they eat, the trauma they might endure, all of that acts like an interior decorator. Life uniquely wires and decorates the pathways of every single brain out there. And a major part of that rewiring happens through memory. When you form a new explicit memory, like just remembering what you ate for dinner yesterday, it starts in this little seahorse-shaped structure called the hippocampus. But the hippocampus isn't a permanent storage vault, okay? It's more like a bank teller. It receives the memory, and over time, it distributes that memory across that vast pizza-sized cortex we talked about earlier. That's exactly why in older patients with dementia, the hippocampus might be damaged, so they can't form new memories, but they can still remember super vivid details from 50 years ago, because those old memories are already safely distributed across the wider cortex. Okay, Section 3, the mechanics of addiction. Now we get to see what happens when this incredible operating system gets hacked. Let me ask you this, and be honest, because we all struggle with it. Why is it so incredibly hard to just put our phones down at night? We tell ourselves, oh, okay, I'm not going to scroll, but we do it anyway. It's absolutely vital to understand that this isn't simply a moral failing. It's not a lack of character. It is a literal biological hijacking. See, evolution built a motivation circuit in our brains specifically to ensure we survive. We get a healthy hit of dopamine, which is the reward chemical for natural life-sustaining behaviors, things like eating food, staying hydrated, or socializing. But modern life has introduced these hijacked rewards, endless social media scrolling, refined sugar, gambling, alcohol. And these things hijack the exact same baseline survival circuits. Here is the actual plumbing behind that loop.
Deep in your brain, the ventral tegmental area, or VTA, produces dopamine and shoots it right over to the nucleus accumbens. Natural rewards give you a normal, healthy dose. But hijacked rewards, like pulling the slot machine lever of a social media feed, they flood the system with a massive, completely unnatural spike of dopamine. When that happens over and over again, your brain builds a tolerance. Your baseline for pleasure just gets ruined. Normal life suddenly feels totally boring, and your prefrontal cortex, the logical part of your brain that's supposed to give you willpower, gets completely overpowered by the sheer biological craving for that next massive dopamine hit. That brings us to Section 4, Understanding Modern Anxiety.
Let's dive into another major software glitch. What actually happens when the brain's internal alarm system malfunctions? It all centers around a tiny almond-shaped structure called the amygdala. The amygdala is your brain's ancient threat detector. Dr. Vaidya uses a really great analogy here. If there is a wild tiger in the room with you, your amygdala triggers a massive life-saving physiological response so you can run away. But anxiety? Anxiety is when your body reacts identically to a tiger being in the room, even when the room is completely empty.
When that amygdala sounds the alarm, boom, it activates your sympathetic nervous system. This is your classic fight-or-flight mode. Your heart races, your palms start sweating, your digestion literally shuts down, and your body floods with the stress hormone cortisol. It is preparing you for actual physical combat. The exact opposite of this is the parasympathetic nervous system, which manages your rest and digest functions. The big problem with modern anxiety and panic attacks is that the sympathetic system completely takes over. It causes very real, absolutely terrifying physical symptoms for threats that are entirely psychological. Our bodies are beautifully designed for acute, short-term physical threats. You see a tiger, your cortisol spikes, you escape, and your body goes back to normal. But modern society bathes our brains in chronic social stress. A toxic boss yelling at you or facing exclusion on social media, those trigger the exact same biological tiger response. But because you can't physically run away from your boss or your smartphone, you end up with a constant, never-ending drip of cortisol. And let me tell you, this chronic social stress literally accelerates aging, disrupts your immune system, and causes severe burnout. It's a huge deal. And finally, Section 5, the neuroscience of willpower.
So, how do we actually fight back? How can we use our massive, pizza-sized cerebral cortex to take back control of our hardware? It's pretty fascinating to see how different high achievers wire their brains for success. Take Michael Jordan. He mentally rehearsed the exact physical movements of a basketball shot thousands of times, engaging his motor cortex and his striatum. He was heavily process-driven. Michael Phelps, on the other hand, heavily utilized his prefrontal cortex. He vividly imagined negative outcomes, like his goggles breaking during an Olympic race, and mentally practiced overriding that panic to secure a win. Then you have someone like Napoleon, who operated largely out of his amygdala. He was purely fear-driven, imagining every way he could die in battle and fighting just to survive. All three were ultimate winners, sure, but operating out of sheer fear and survival, like Napoleon, will continuously flood your brain with cortisol and eventually fry your nervous system. Because of that, the secret to sustainable willpower really isn't fear. It's finding an endeavor where you actually love the process itself. Dr. Vaidya asks 3 really difficult questions. Do you love the work? Are you willing to put in the immense daily effort required? And here's the hardest one. If you didn't ultimately get the outcome you dreamed of, would the process of trying have still given you joy? If you can answer yes to that, you've found a path where willpower isn't some massive struggle. It just becomes a natural byproduct of your engagement. But listen, you can also train willpower just like a physical muscle at the gym. You do this by deliberately subjecting your prefrontal cortex to hard, uncomfortable tasks. Dr. Vaidya calls these neurobics. Try learning a completely new, incredibly difficult language, or maybe pick up a musical instrument where you're forced to sound terrible for a long time before you sound good. Practice delaying immediate gratification, maybe through short-term fasting, purely to prove to your brain that it can override a craving. Even just doing small everyday things differently, like walking backwards safely or brushing your teeth with your non-dominant hand. It forces your brain off autopilot and builds incredible cognitive resilience. Which brings us to the end of this explainer, and I want to leave you with one final provocative thought to mull over. Your brain is a dynamic living ecosystem, and you actually have the power to shape it every single day. So what new, difficult task will you subject your brain to today in order to build your own cognitive resilience? Don't let your biology hijack your habits. Take the wheel, train your cortex, and start rewiring your brain for a better tomorrow. Thank you so much for joining me in this explainer, and keep learning.